Hey, Sci30, this is for Unit C, Chapter 1, Section 3, Motors and Generators. Many devices convert electrical and mechanical energy. Consider the headphones and microphones. Both involve conversion between mechanical and electrical energy. The difference between the two is the order of the energy conversion. What is the order of the conversion in microscopes? Oh, sorry, microphones. So when you get a sound wave going into a crystal microphone and then the wire inside the microphone, you're going from a vibration, which is mechanical, then it moves into a crystal, which is inside the microphone, which is one mechanical to another mechanical, and then that is then converted to an electrical stimulus, which is where the wire, down the wire. So the electric current travels down the wire, and that's electrical, and that hits an electromagnetic speaker. So if you ever notice that sometimes your headphones can actually are magnetized, so that's magnetism. Then it travels through the air, and that's a vibration that's mechanical. Hits your eardrum, that's also that would be also mechanical. And then when it gets into your brain, it's actually converted to a chemical signal. So now when you consider your sense of hearing involves energy conversions, are converted to signals that are sent to your brain, what is the order of conversions occurring in your brains? Well, your sense of hearing, involves the same basic process as a microphone. The mechanical energy of the vibration is converted into an electrical signal. However, the case of hearing, the electrical signal is transmitted biochemically through nerve cells instead of through wires. Okay, so when we take a look at this next page, we've got the number of coulombs pass every second. Measure in amps is equal to 1 coulomb passing in a wire every second. So if more charge passes through every second, the current is larger. So in the example that I have here is from the textbook from page 356. Get a wire, 4 coulombs in 2 seconds. 4 coulombs every 2 seconds is equal to 2.0 amps. You have a second wire, which there's 8.0 coulombs in 2.0 seconds, means that there's 4 amps. So this has the greater current flowing through it. So in the question here, a refrigerator requires 3.8 times 10 to the power 3 coulombs moving charge to flow through the coil of a compressor motor over a time of 15 minutes. Calculate the current required by this motor. Okay, so we've got the formula is I, which is equal to current, is equal to the Q, which is the coulomb, divided by time. The time is in 15 minutes. The conversion is 60 seconds per 1 minute. And then you have to cancel some stuff off. Minutes cancel off. You're left with something in seconds. And then this is 900 seconds, which means that you end up getting a number that is 4.2 amps repeating. In a speaker wire, 4.0 coulombs pass through a certain point in 2 seconds. Calculate the current in the speaker. So following the formula again, current is equal to coulombs divided by time. 4 coulombs divided by 2 seconds is equal to 2.0 amps. The compressor motor with a large refrigerator requires 1.12 times 10 to the power of 4 coulombs to charge pass through a segment of a wire on one of its coils while running for 30 minutes. Determine the current that passes through the wire segment as the motor is running. So Q is equal to the amount of coulombs, 1.12 times 10 to the power of 4 coulombs for 1800 seconds, which means that this is going to work out to 6.2 amps. So describe the energy transformation that occurs within this device. So when you're looking at the device that's in the handout, the device takes input from the electrical energy and converts it into mechanical energy of the rotating shaft. Since the shaft is connected to the energy of the shaft is transferred to kinetic energy, the turning does the work on the surrounding air, creating kinetic energy, which is then ends up moving the air around. So if you're looking at a magnet and you're looking inside, well, inside a permanent magnet there's always going to be a portion of that magnet that is the North Pole and a portion that's going to be the South Pole. Okay, in step 5, the coils are shown mounted on the axle. Identify the name of this whole piece. Okay, so that would be the armature, which is the spinning portion. So identify the name of the 3 separate contacts at the end of the axle. Well, they can have more than 3. 2 is common, then it's 3, 4, whatever. It's called a commutator, and there's usually an insulating gap between them. Okay, suggest the function of the iron core for each called a core. Intensifies the magnetic field. Identify the proper name for these metal contacts. They're the brushes. That's what, and they're usually solid and in one spot. They're stationary, and they transfer electric current. Suggest a reason why these contacts are made from thin, light material that are spring-like. Well, they're light so that they can spin freely. And they're spring-like so they can apply light pressure. Okay, this is from page 364, number 1 to 3 in your Sci30 textbook, Physics unit, chapter 1. So what we got here is it's asking for a question about the differences between device 1, 2, and 3, and how do you determine it. Okay, so device 1 is a generator because it has mechanical energy, because this is falling. The clips are falling, which is then causing this to spin. So this is mechanical energy supplied by the falling clips, and the output is electrical. So this would then be a generator producing power. Now it's got a slip ring which is right here. That's important to realize, and then that will act as a source of AC, as an AC generator. Number 2, device number 2, you notice how it's moving up and it's rotating this way. So so this would be and you'll notice that there is a battery here. Well, that would be direct current then. So if that's direct current and this is moving up, this would have to be a DC generator. Now it also has a split ring. You've got a little split ring right here. Same type of split ring that's here, and that makes that allows this to spin, and then there's like spins quickly, then there's a little bit of gap, spins quickly in a gap. Okay, so this is the DC generator, and the output is mechanical. The third one, the clips are falling. It's rotating this way. So this would be this would end up being a generator, but it has it also has a split ring, and so then because it has a split ring, it's spinning in one direction, and then that would then make it a DC generator. Now, you'll notice some of the terms that are here. So where does everything line up? Okay, so A, which is right there, is a rotating coil. Okay, B, which is here, is a brush, because that's what's touching this ring here. Okay, then from there you've got C being a voltmeter, because that's what it's measuring. Then you've got D are permanent magnets, so you got D permanent magnet there. You've got E, which is where's E? E is the slip ring. So slip rings are associated with AC generation, slip ring. Then you've got F. Sorry, oops, F is a split ring commutator, and you'll notice that H is the exact same thing. So both of these are for DC power. In this case, this is for the generator, and this is for the this is for the motor, and this is for the generator. And then the last one is G, which is a source. In this case, it's a DC source. The third one is asking, well, what's going on here? Copy the diagram, and you end up getting, this would be a headphone here, and then this would be the microphone right here. And in case you missed it, you've got the answers for all of this here. I'll just leave it there for a moment. And that brings us to the end of 1.3.